This is Orkun Yilmaz speaking. First of all, thank you very much for joining my presentation. And thanks to Eurovent Middle East as well for giving me this chance to share a bit of our knowledge and experience about hygienic air handling units, especially in these times. Yeah. In this presentation, first of all, I'm going to talk about the air handling units and hygiene concept. Then I will explain the main standards regulating the hygienic AHUs. I'll explain the basic principles in summary, as I only have 10 minutes for the presentation, and conclude it hopefully in time, inshallah. Okay, this is the definition of AHU according to Eurovent. It's a device suitable to be used with ductwork while performing one or more of these functions. Air circulating, filtration, very important, especially in these times, as I explained before, heating, cooling, energy recovery, humidifying, dehumidifying, and mixing. Okay, but what else happens in an air handling unit in time? Metallic parts may corrode in time. Microorganisms may grow on the non-metallic parts, such as plastics. If a unit is not meant for being hygienic or for a special application, it's usually kept as compact as possible. As you know, especially on length of the unit, then the unit may not always have enough space for servicing or cleaning. Also, its construction could allow dust and dirt to accumulate in some edges or corners or gaps in the unit, in the airflow, and the casing could have risky levels of leakage or thermal bridges. So it doesn't like much hygienic, right? Okay, but what does hygiene mean? In Cambridge Dictionary, very shortly, it's defined as the degree to which people keep themselves or their environment clean, especially to prevent disease. And if something is hygienic, it's clean and unlikely to cause illness. Then it's more or less clear what we expect from an hygienic air handling unit. It's an AHU which conforms to different hygiene levels defined by specific norms with respect to the site or application that it will be operated in. And it helps preventing diseases thanks to its enhanced design features. Relevant standards, in fact, there are a bunch of these, especially if we consider the local ones, but I will mention the most widely known and well accepted norms about this, which are the German Engineers Association's VDI 6022 Part 1, Hygiene Requirements for Ventilation and Air Conditioning Systems and Units. It specifies the hygiene requirements from an interdisciplinary perspective, and it's a well accepted guideline for hygienic applications. German Standard Institute's DIN 1946, ventilation in buildings, and Part 4 actually explains the ventilation in buildings and rooms of healthcare. It applies to ventilation and air conditioning systems used in the health sector specifically, particularly those used for medical examinations and operations on humans in hospitals, operating rooms, dialysis centers, and so on. So we can say that it's more specialized hospital units, let me say. It classifies the rooms in two classes, class 1 and 1A and 1B, being for the surgery rooms, and class 2 is for the rest of the hospital areas. And then the rating standard from Eurovent, the RS6C11 2018, which is also getting more and more attention every day, describes 3 levels of hygiene. Third one being the highest requirements recommended for the food processes, pharmaceutical and white rooms and equivalent. Level 2 is for hospitals, and level 1 is for recommended for schools, offices, and hotels. In this section, I'll try to summarize the requirements of a hygienic air handling unit so that you have a better understanding of how it differs from a standard AHU and why it is important. The basic principles can be grouped as follows: accessibility of components, cleanability of the components and the unit, materials used in the unit construction, mechanical characteristics of the casing, selection and sequence of the components in a unit, and labeling and documentation requirements as well. Accessibility. When we say accessibility, what we mean is that all components in the unit shall be easily accessible from both sides and shall be easily removable without a big effort up to a certain height of 1.6 meters per section. On the screen, you can see an inspection section is added in between the cooling coil and heating coil, allowing the service people to reach coils easily for inspection and cleaning purposes. Eurovent rating standard clearly defines how much service space shall be spared with respect to unit dimensions and hygiene levels, as you can see on the table on the screen. Actually, I like this table. By the way, it leaves no comment or discussion about necessary inspection space, unlike the other above mentioned norms. Cleanability, yeah, it explains itself. Inner surfaces shall be smooth and flat without grooves to allow easy cleaning, and casing materials which come into contact with the airflow shall be resistant to disinfectants. Materials used in a hygienic air handling unit construction are extremely important when we talk about hygiene purposes. Non-metallic materials shall be tested and validated with respect to ISO 846 standard, which is the evaluation of the action of microorganisms on plastics. Sorry. Drip trays, drain pan shall be made of stainless steel. Ceilings shall have closed cell structure so that it doesn't suck in any humidity. And there are some specific rules in some norms for the door ceilings as well. Inspection lighting should be also cleanable. It's mandatory in some sections, but take care that it's cleanable, because as you can see the example on the screen, which is a ship fitting, it's not recommended for hygienic unit because it's not easily cleanable. Mechanical characteristics of the casing is another requirement in hygiene norms. For different classes of hygiene levels, casing of a hygienic AHU shall comply with some minimum classes with respect to EN 1886. Regarding the casing strength, casing air leakage, filter bypass leakage, thermal transmittance, and thermal bridging. Components. For the components used in an AHU, hygiene norms define some specific requirements or types to be fulfilled, as already explained about filters and heat exchangers in the previous presentations. I will talk very shortly about that. For example, for the fans, plug fans are recommended, as centrifugal fans with housings have difficulty in cleaning and has a risk of dirt accumulation in time. Filters for the first and second filtration stages, DIN norm also asks for EPM1 60% for the first filtration stage and 85% for the last filtration stage, previously known as F7 and F9, as a minimum class. Dampers, according to EN 1751, minimum class 2 dampers are required, whereas for higher hygiene requirements, it should be class 4. There are many more requirements for the coils, sound attenuators, humidifiers, and so on, which basically depend on the same principles explained before about the materials, corrosion resistance, cleanability of the design, and so on. But it's not only the materials or selection of the components what affects the hygiene level of a unit, but also the sequence of the components. For example, if you look at these sequence of the components, while selecting the unit, make sure you do not position the humidifier directly upstream a filter or a sound attenuator in order not to make them wet. Also, a wet cooling coil like here should not be positioned directly upstream a filter or sound attenuator. Yeah, it's in the previous presentation, Stefan explained very well about the energy recovery types and the usage of them. Actually, on hygienic units, it's one of the most critical component in the unit. That's why actually the DIN norm allows only runaround coils for surgery rooms, which has a zero cross-contamination risk and plate types are only allowed when certain conditions are fulfilled. For now, rotary wheels are not allowed in DIN norm, whereas Eurovent and VDI allows rotary wheels as well. Yeah, an example of a handling unit with a runaround heat exchanger. And yeah, Eurovent and VDI, they also allow the rotary wheel as well. But again, if some conditions are fulfilled, as explained before, it's mostly related to the permitted level of EATR, the exhaust air transfer ratio. And also the rotary wheel shall always have a properly dimensioned purging sector, otherwise it's too risky and not allowed for a hygienic air handling unit. Now let me present some hygienic AHU selection examples, also explaining the EATR concept on the unit as well. EATR is, as explained before, it's the air going from extract to supply, from here to here, through the rotary wheel sealing as a leakage or in storage matrix of the rotary wheel, which is known as carryover. This means that the outdoor air to be supplied to the hospital is contaminated by the return air, the extract air, which must be prevented or kept at minimum levels. So how can we secure it is already explained. The example on the screen is just one of the possible combinations where you keep the supply side of the rotary wheel on positive side, and as you can see, the extract side is on negative pressure, so we don't expect air to leak from here to here, as Stefan explained very well in his presentation. Also, it's the same principle for the plate heat exchanger as well. The pressure on supply side of the plate heat exchanger should be positive related to the pressure on the extract side. Here, the plate heat exchanger is on upstream the fan, so there is some positive side. It can be used on a hygienic unit. Yeah, this is another selection example where a runaround coil is used. You can see the this is the extract air side, and this is the supply air side. You can see the inspection areas. Inspection windows are positioned at least at fan, filter, and humidifier and inspection sections in hygienic units. Filter classes are as defined in the DIN norm and as explained before. EPM 160 for the first filtration stage, and the last stage it should be EPM 185 or F9 as known before at a minimum. Damper positioning are at outdoor air side as required, as you can see here. Drip trays are also positioned as required in the norms, one at outdoor intake air section, and below the cooling coil and runaround coils. Labeling and documentation. Yeah, it's not only the design and construction of the unit, but the operation and maintenance of the complete system is also covered in these standards. For example, the IOM shall clearly explain how to clean and disinfect the unit. Also, the filter and fan labels shall include some more specific information compared to what's required in standard air handling units. So, in a nutshell, for an AHU to be hygienic, it has to comply with the requirements mentioned in related norms grouped as accessibility requirements, cleanability, materials, casing, mechanical properties, components, selection and sequence of them, and labeling and documentation. Well, that's all from me. Thanks for listening, and you're always welcome to contact me for further information and discussion.
Thank you, Orkun. If I can ask you one simple question, would be like a lot of people are now looking for hygienic air handling units. How much of a difference do they make for the COVID situation? What is your opinion about that?
Yeah, actually, the hygiene norms define the filtration requirements very well and very clearly, especially the DIN norm and Eurovent guidelines. And also, for the time being, you can see that HEPA filters are more widely talked about in the market, and also the UVC lights could be added in the units, but there are really important things to be considered when using UVC lights and also the HEPA filters. You should make sure the filter bypass class of the casing is at a minimum level of what filter you are using in the unit. For example, if the unit's model box test result is like M5, F7, something like that in the old classification. If you put a F9 filter in that, it doesn't make any sense because of the bypass around the filter. So the filter will not work as expected. So that's also the same principle for HEPA filters. So HEPA filters are not expected to be mounted in the unit, but in the ducting with a HEPA frame around. So these are the things to be considered on a unit.